In this lesson, I will talk about symmetry with respect to the x-axis, the y-axis, and the origin. A graph that is symmetric about the x-axis will look the same when reflected about the x-axis. To test an equation for symmetry about the x-axis, substitute x, negative y, into the equation and simplify. If the result is equivalent to the original equation, the graph is symmetric about the x-axis. Here is a graph that is symmetric about the x-axis. Note that if the point xy appears anywhere on the graph, the point x negative y must also appear on the graph. Let's try testing an equation for symmetry about the x-axis. We'll substitute y. We have y squared equals 4x plus 8. We'll substitute negative y for y, leaving x as x, and simplify. Negative y squared is equivalent to y squared, resulting in our original equation. Thus, this equation, the graph of this equation, would be symmetric about the x-axis, as we can see here. A graph that is symmetric about the y-axis will look the same when reflected about the y-axis. To test an equation for symmetry about the y-axis, substitute negative xy into the equation and simplify. If the result is equivalent to the original equation, the graph is symmetric about the y-axis, as we have here. On this graph that is symmetric about the y-axis, note that anytime the point xy appears on the graph, the point negative xy must also be on the graph. Let's try testing an equation for symmetry about the y-axis. Here we have y equals absolute value of x minus 2. We'll leave y as it is, replace x with negative x, and simplify. The absolute value of negative x is equivalent to the absolute value of x, resulting in y equals absolute value of x minus 2, our original equation. Thus, this graph is symmetric about the y-axis. But what about the x-axis? Remember, to determine symmetry about the x-axis, we replace y with negative y, giving us negative y equals absolute value of x minus 2. If I multiply each side of my equation by negative 1, I simplify the equation to y equals negative absolute value of x plus 2. This is not equivalent to our original equation, and thus this graph is not symmetric about the x-axis. If you look at the graph in this picture, you will see that the graph does appear to be symmetric about the y-axis, but not about the x. A graph that is symmetric about the origin will look the same when rotated 180 degrees. To test an equation for symmetry about the origin, substitute negative x, negative y into the equation and simplify. If the result is equivalent to the original equation, the graph is symmetric about the origin. As we can see in this graph that is symmetric about the origin, anytime the point xy appears on the graph, the point negative x, negative y will also appear. Let's test an equation for symmetry about the origin. We have y equals x cubed over 2. And to test for symmetry about the origin, we replace y with negative y, x with negative x. Recall that negative x cubed is the same as the negative of x cubed. Multiplying each side of our equation by negative 1 gives us y equals x cubed over 2. Again, the same as our original equation, proving that the graph of this equation will be symmetric about the origin, and we can see that here. let's test an equation for symmetry about the x-axis, y-axis, and the origin. We have 4x squared plus y minus 3 squared equals 4. I'll start with testing for symmetry about the x-axis, replacing y with negative y. And what makes me a bit suspicious right off is I have negative y minus 3, and it just makes me wonder if there's any way I could end up with the same equation as y minus 3 squared. So I'm going to jump to looking at the graph of this equation. And if we look at the graph, we'll see that to be symmetric about the x-axis, the point 0, 1 appears on this graph. We would have to have the point 0, negative 1 appear, which doesn't seem to be the case. So I'm going to use the fact that the point 0, negative 1 is not on this graph to verify that this equation does not give us a graph that is symmetric about the x-axis. Moving on to testing for symmetry about the y-axis, we replace x with negative x. And we end up, after simplifying, with the original equation, verifying that the graph will be symmetric about the y-axis, as you can see in a graph that's been sketched here. To test this equation for symmetry about the origin, we will replace x with negative x and y with negative y. Again, this negative y minus 3 squared makes me suspicious, and so I'm going to cheat and take a peek at the graph. In order to be symmetric about the origin, the point 0, 1 is on my original graph. If we reflect this graph 180 degrees about the origin, we would have to have the point 0, negative 1 on the graph, and that does not appear to be the case. And so I'm going to use that fact to verify that this graph is not symmetric about the origin. Here's one to try on your own. Test x plus 1 squared plus y squared equals 4 for symmetry. If the equation appears to fail any of the symmetry tests, find a point on the graph of the equation whose reflection fails to be on the graph.